Hi, Frank Stover with Regal Boats. I want to talk to you a little bit about galvanic corrosion. We're going to talk about what it is, how do you diagnose problems with it, and of course, how do you solve those problems once you identify them. Let's start with what it is. It's actually pretty simple. It seems a mystery to most people, but in theory all it is dissimilar metals and an electrolyte. In this case, the electrolyte would be seawater or water. There's two metals, one on each end of the scale that I'm going to talk about. You'll have magnesium, which is a very active metal, and then you'd have stainless steel on the other end, which is inactive. There certainly is different ones in between. You could have zinc and aluminum, and then you get into steels and coppers and bronzes. The reality of it is, on this scale, the farther apart that they are on the scale, and then you put them into the water, you end up with a battery. So the more activity is based on how far apart that they are. Now, there's some things that can aggravate this. Aerated water, water that's flowing, water that also has acids in it. You know, sometimes you get trees. Tannic acid from cypress trees can aggravate this situation. There's a number of things that can exasperate it. But in theory, all we really need to do is test, and from that test, we can tell whether or not we've got the protection we need. Here's the principle behind it. Let's say I have an aluminum gear housing, which is right here. To protect it in seawater, I want to put a more active anode on it. I'm either going to put zinc or magnesium. Magnesium would typically be fresh water. The theory is this will eat up and sacrifice itself before the aluminum gear housing. So what happens once this gets eaten up or crusted over, then we shift to the gear housing. When we're doing this test, which we'll show you in just a minute, we should be between 600 and 1,000 millivolts. It's a very low flow, but it doesn't take much to destroy these housings. Ideally, what we're going to do is make sure that we have enough and the right protection in the water in which we're located. Let's go out to the water and we'll do this test. Hey, we're out here at Regal's test basin. I want to show you how to do this test. You've noticed I've acquired an ugly hat. That's what happens when you have a bald head. Very simple to do this test. You're going to need a couple of things. First of all, you're going to need a silver chloride half cell. It's basically a piece of silver coated wire wrapped around a nylon rod, but it is calibrated. You can't really make this thing yourself. I'd suggest you buy this one from Quicksilver. These are the Mercruiser folks. They produce it, it works, they test it, it's calibrated, you can count on it. The other thing that you're going to need is a digital voltmeter. You want a pretty decent one here. You don't want to be chasing your tail because of a bad meter, so get a decent meter. To put this thing into order, basically you're going to take your negative lead and you're going to put it in the positive volt terminal. Then you're going to put the silver chloride half cell in the common or in the negative. Don't ask why, just do it. The instructions will tell you that with what comes in the box as well. We're going to take the probe itself, drop it down in the water, making sure it's down there a foot or so. Then we're just going to take this meter and we're going to touch the gas fill. Now the reason I'm touching the gas fill simply is because it's hooked into the boat's bonding system. That'll give us the ground that we need to complete the circuit to do the test. As I mentioned earlier, a good reading will be between 600 and 1,000 millivolts. That means we're protected. We're in a range where the drives and the components that we want to live will be protected. Now you can see here we're around 680. That means we're protected, but we're kind of on the bottom end. Let me just show you something here that you might find interesting. I'll go ahead and set this meter up here, or it'll stay by itself. I've got an anode back here on the back. I'm just going to take this anode, this zinc anode, and I'm going to interject it into this scheme. I'm going to put it in the water here. Now that it's in the water, I'm going to go ahead and I'm going to touch it into the circuit. Put the meter back on. You'll see with that 670 number, I'm going to touch the anode. As soon as I touch it, I'm well up over 700 now, 706, 710. The longer I leave it in there, the more it'll go up. It'll probably stabilize someplace around 720. But you can see how just putting that one little anode in the circuit changes it. You can see the results from the test. So let's talk about what happens if I'm below that 600 number, which means I'm not protected. The first thing we want to do is make sure we don't have a problem coming from the shore power. It's very simple to do. Unplug the shore power cord and then take another reading. If it affects your reading, then you've got a problem in more than likely your battery charger. all of this is related to DC. Remember, we set the meter on DC. It's not an alternating current problem. If you don't get a change there, the next thing to do is to disconnect the negative terminal on the batteries. This will isolate the boat's 12-volt system from the bonding system so you can't pick up any outside influences. If you get a change there, then reconnect it and start disconnecting things one at a time. I would suggest you start with the automatic bilge pump. That's got a connector that sometimes falls into bilge water, which again can touch the through hulls, which gets into the bonding system. But it's a divide and conquer theory. Once you identify the problem, then you start disconnecting things one at a time until you find the problem. But let's go back just a little bit. Let's say that you disconnected the batteries, you've disconnected the shore power, and you still have a reading that's out of whack. What you're going to want to do is take the boat from its current position and move it to a new location. There could be something about this dock that's creating it. This is an aluminum dock. If some of this aluminum dock is in the water next to this boat, it's going to give you a number that maybe is not going to work for you. With that fact in mind, you got to use some common sense. Now, one of the things we're going to put on this video right at the end is a flow chart. It's a diagnostic flow chart to teach you how to do this. Basically says if you get this number, do this. If you get this number, do that. It'll kind of lead you through the process. Hopefully this little video will help you diagnose the problems that you have out there in the field. This is a problem that nobody really wants to pay for when it comes up. Drives are expensive. Customer doesn't want to pay for that. The whole situation is never a good one. So you really need to do these checks. I would suggest you do them when you deliver a new boat to the customer's dock. Make sure he's in good shape before you leave. Thanks again for watching.